So today we have a very important point, and that is task number 2 from the network exploitation basics from complete beginner path. We have the OSI model, which is one of two very common networking models. And the second one, which is more used today, is the TCP/IP model, which we'll read about in task number 4. Basically, the need of this model was because prior to the OSI model, there was no standardization, meaning that if you wanted to access the internet, you had to buy a specific vendor, hardware and software in order to access something. So the need for some standardization, and in order to be everything in one place, in other words, you can buy any kind of hardware and software and access the internet without any special or limited equipment. The OSI comes from Open Systems Interconnection model. Is a standardized model which we use to demonstrate the theory behind computer networking. In practice, it's actually the more compact TCP/IP model that real-world networking is based off. So, in other words, the OSI model is used for theory, but for practice is the TCP/IP model. However, the OSI model in many ways is easier to get an initial understanding from. The OSI model consists of 7 layers, and they are from top to bottom. Application layer, layer 7, presentation 6, session 5, transport 4, network 3, data link 2, physical number 1. There are many mnemonics floating around to help you learn the layers of the OSI model. Search around until you find one that you will like. I personally favor anxious, pale, Shakespeare, treat nervous, drunk, patiently. So these are the acronyms, right? The first letters for every 7 layers. Let's briefly take a look at each of these in turn. Layer 7, application. The application layer of the OSI model essentially provides networking options to programs running on a computer. It works almost exclusively with applications, providing an interface from them to use in order to transmit data. When data is given to the application layer, it passes down into the presentation layer. This will be known as encapsulation, which will go in task number 3. Layer 6, presentation. The presentation layer receives data from the application layer. This data tends to be in a format that the application understands, but it's not necessarily in a standardized format that could be understood by the application layer in the receiving computer. The presentation layer translates the data into a standardized format, as well as handling any encryption, compression, or other transformations to the data. With this complete, the data is passed down to the session layer. Layer number 5, session layer. When the session layer receives the correctly formatted data from the presentation layer, it looks to see if it can set up a connection with the other computers across the network. If it can, then it sends back an error and the process goes no further. If a session can be established, then it's the job of the session layer to maintain it, as well as cooperate with the session layer of the remote computer in order to synchronize communications. The session layer is particularly important as the session that it creates is unique to the communication in question. This is what allows you to make multiple requests to different endpoints simultaneously without all the data getting mixed up. Think about opening 2 tabs in a web browser at the same time. When the session layer has successfully logged the connection between the host and the remote computer, the data is passed down to layer number 4, the transport layer. Layer number 4, the transport. The transport layer is a very interesting layer that serves numerous important functions. Its first purpose is to choose the protocol over which the data is to be transmitted. The 2 most common protocols in the transport layer are TCP and UDP. TCP, you already know it from our second networking model, TCP/IP. TCP comes from Transmission Control Protocol and UDP comes from User Datagram Protocol. With TCP, the transmission is connection-based, which means that the connection between the computer is established and maintained for the duration of the request. This allows for a reliable transmission as the connection can be used to ensure that the packets all get to the right place. A TCP connection allows the 2 computers to remain in constant communication to ensure that the data is sent at an acceptable speed and that any lost data is resent. With UDP, the opposite is true. Packets of data are essentially thrown at the receiving computer. If it can't keep up, then that's its problem. This is why a video transmission over something like Skype can be pixelated if the connection is bad. What this means is that TCP would usually be chosen for situations where accuracy is favored over speed. For example, file transfer or loading a web page, and UDP would be used in situations where speed is more important. For example, a video streaming service. With a protocol selected, the transport layer then divides the transmission up into bite-sized pieces. Over TCP, they are called segments. Over UDP, they are called datagrams, which makes it easier to transmit the messages successfully. Layer number 3, network. The network layer is responsible for locating the destination of the request. For example, the internet is a huge network. That's it. Basically, that's the internet. And there are different terms, dub, that people use in order to define the network, or HTTP. Even a network is referred as the internet, which is the internet is basically a huge connection of networks. Dub is a collection of web pages, and HTTP is basically the protocol used in order to access a web page, right? It's just the HTTP is used to connect your web client, which is your browser that you choose, Chrome, Firefox, or whatever, with a web server. Pretty simple. When you want to request information from a web page, it's the network layer that takes the IP address for the page and figures out the best route to take. At this stage, we're working with what is referred to as logical addressing. That is the IP address, which are still software controlled. Logical addresses are used to provide order in networks, categorizing them and allowing us to properly sort them. Currently, the most common form logical addressing is the IPv4, which you'll likely already be familiar with. Here we have an example of a IPv4 address, which is a common address for a router, right? The last two ones 192.168.1.1. Then we have the layer number 2, data link. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer that includes the IP address for the remote computer and adds the physical address, which is the MAC address of the receiving endpoint. Inside every network-enabled computer is a network interface card, which is a NIC, which comes with a unique MAC, media access control address, to identify it. Oh yeah, here we say, here it's said, MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed. Yes, they can, although they can be spoofed, so you can change. When information is sent across the network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it's also the job of the data link layer to present the data in a format suitable for transmission. The data link layer also serves an important function when it receives data, as it checks the received information to make sure that it hasn't been corrupted during transmission, which could well happen when the data is transmitted by layer 1, the physical layer. The physical layer, layer 1, the physical layer is right down to the hardware of the computer. This is where the electrical pulses that make up data transfer over a network are sent and received. It's the job of the physical layer to convert the binary data of the transmission into signals and transmit them across the network, as well as receiving incoming signals and converting them back into binary data. For the which layer questions below, answer using the layer number. Okay. Answer the questions below. Which layer would choose to send data over TCP or UDP? Number 4, transport layer. Which layer checks received information to make sure that it hasn't been corrupted? If we go here, we can see the data link layer also serves an important function when it receives data, as it checks the received information to make sure that it hasn't been corrupted during transmission, which could happen when the data is transmitted by layer 1. So it's Número 2, data link. In which layer would data be formatted in preparation for transmission? Layer número 2. Which layer transmits and receives data? Transmits them across the network as well as receiving incoming signals. Layer 1. Which layer encrypts, compresses, or otherwise transforms the initial data to give it a standardized format, as well as handling any encryption, compression, or other transformation to the data. Number 6, presentation. Which layer tracks communications between the host and receiving computer? If a session can be established, then it's the job of the session layer to maintain it. If it can't, then it sends back an error and the progress goes no further. Number 5, session. Which layer accepts communication requests from applications? It works almost exclusively with applications, providing an interface for them to use in order to transmit data. 7. Which layer handles logical addressing? We can see here the IPv4. Here we can see logical addressing is the IPv4 format. Numero 3, networking. When sending data over TCP, what would you call the byte size pieces of data? If we go here, you can see over here, transmission up into byte size pieces over TCP are called segments, and over UDP are called datagrams. Research. Which layer would the FTP protocol communicate with? We just copy this. File transfer protocol works on the application layer, the same layer on which HTTP works. 7. Which transport layer protocol would be best suited to transmit live video? UDP. User Datagram Protocol.